In this session, we'll start the first topic of thermal physics, which is about the kinetic molecular model of matter. So, basically, what is kinetic molecular model? To explain the matter, the states of the matter, such as solid, liquid, and gas, their particles, the movement of the particle, the behavior of the particle, arrangement of the particle, that we discuss in kinetic theory. So, in this chapter, you will learn mainly about how the particles are arranged in solid, liquid, and gas, and the changes in the state which can occur. So the first thing, this is a learning objective, so you should be able to state of matter, state the distinguishing properties of solid, liquid, and gas. So the first topic of kinetic model of a matter, the three states of the matter, what we have a solid, liquid, and gas. In solid, the particles are tightly packed together. In liquid, the particles can move around each other, but it cannot be compressed. Where in gases, the particles are free to move and the particles are moving at high speeds. So the states of the matter, there are three states of the matter, that is solid, liquid, and gas. Then what are the properties of the matter? The state, number one, the solid. All solid particles are very close or tightly packed together. The molecules are arranged in a regular pattern, and when the molecules are arranged in a regular pattern, we use the term lattice. So lattice is a term used for regular arrangement of the particles. The molecules can vibrate about the fixed position, but they cannot change the position, and the force of attraction between the molecules is very strong. And solid have a fixed shape and it is having a fixed volume. And solid cannot be compressed because particles already they are close to each other, so we cannot further reduce the size. And this is how the internal structure of a solid appear to be. Is it clear, the first part, the properties of a solid? Anyone having a doubt or a question? Then the second state is liquid. What happens in liquid, the particles are closer together, but compared to solid they are little far. Compared to solid they are little far, but relatively they are closer. Attractive force between the molecules are weak compared to that of solid. The molecules can move from one place to another or move past each other, and liquid does not have a fixed shape, but it is always have a fixed volume. And liquids are also, it is not, we are not able to compress them easily. So these particles, as you can see, these particles can move around, move past each other, but the total volume occupied by these particles will not change. That's why we say liquids have fixed volume. About the gases, in gases the particles are very far apart. The attractive force between the molecules is very weak. The particles can move randomly at a high speed. So when you compare the speed of the particle in like gases, the particles are moving much faster, and gases does not have a fixed shape or a fixed volume. So they take the shape of the container, and volume depends on which medium or which size of a container. Like example, if you have a large container, then it will have a greater volume. If we transfer the same number of particles into a smaller container, then the volume will also decrease. Then you have to learn the changes in the state. So one of the state can change to other. If a solid is there, we have a solid is turning into a liquid, we call melting. If a liquid turn into a solid, we can say solidify, or we can use the term freezing. If a liquid is turning into a gas, we call vaporization or evaporation, or we can also say boiling. So in this chapter, we'll discuss the difference between evaporation and boiling as well. But what is condensation? When a gas turned back to a liquid, we call that as condensation. If a solid turned into a gas, we call it sublimation. Even a gas turned to a solid also refers to sublimation. You can also say deposition or sublimation is also a right word. So both are acceptable. So these are the properties of the solid, liquid, and gas. Then what is the pressure and temperature of the particles? The qualitative explanation. Qualitative means without using a formula. So how we refer the pressure? So you should be able to explain the pressure exerted by the gas in terms of number of the collision, as well as momentum. So these are the two ways you should be able to explain the pressure exerted by the gas. You should be able to explain in terms of number of collision as well as momentum. What about the number of the collision? Pressure is refers to number of the collision, how many gas molecules are colliding with the surface. So if greater number of gas molecules are colliding or number of collisions are more, then the gas will exert a high pressure. Example, we have two containers of different size filled with equal number of the particles. Which container you think will have the high pressure, A or B? So which container you think will have a high pressure? That's right, B will have high pressure, because in B, as there is small space, so frequently, like the number of the collision per second for B will be higher as compared to that of A. So when there is more collision, it means it will have a greater pressure. And here it is having less collision, so it will exert a smaller pressure. So pressure exerted by the gas depending on the number of the collision the gas molecules are having. The second thing, you should be able to explain the pressure of the gas in terms of momentum. Momentum is a vector quantity. Remember, as we discussed in general physics, the momentum is a product of mass and velocity, where m is a mass and v is a velocity. V or u can be used. Now, how we can explain why the gas molecule exert pressure when it collide with the wall? So sometimes they ask this question, that why the gas molecule exert pressure on the wall of container. Explain in terms of momentum. So how we can explain this statement that a gas molecule is exerting pressure? So example, you have a container which is have filled. Example, only one molecule is there. Practically it's not possible, but we are, for explanation example, there's one molecule m. Now this molecule is moving with velocity v, and it hits the wall and it bounces back. The speed won't change. Like example, the value of this magnitude of the velocity is not changing, but the direction changes. So if right hand side is positive, the left hand side will be negative. So whenever direction changes, there will be a change in momentum. So the first point, when we write, we'll mention when the gas molecule collide with the wall, it changes direction and momentum. Because whenever momentum is a vector quantity, so even though if the direction changes, the momentum will also change. Example here, if a gas molecule was moving and it was having a momentum of 10 kilogram meter per second, but if it changes the direction after bouncing back from the surface, so it will not be 10 kilogram meter per second, it will be minus 10. So due to a change in direction, there is a change in momentum. So first thing what happened, when the gas molecule collide with the wall, it changes the direction and momentum. That's the first point. Now what is the second point? Whenever there is a change in momentum, there should be a force. So when gas molecule changes the momentum, it exert, because momentum cannot be changed without a resultant force, so it exert force on the wall of container. So that is the second point. When the gas molecules, they hit the wall of this container, these gas molecules, what they will do, they will exert force. So there will be a force exerted by the gas molecules on the wall of the container, and the force applied on the unit area will create a pressure. So this is how we explain the gas molecules are creating a pressure. What happened? First thing, this, and you will find in exam it's a 4-mark question. So how you will get all these 4 marks? Number one, you will mention when gas molecules are colliding with a wall, they changes the direction. So when you mention the word changes the direction, you will get 1 mark. And it changes the momentum, you will get the 2nd mark. And whenever the momentum changes, the gas molecule exert force, because to change a momentum there should always be a force, so you will get the 3rd mark. And force is acting on a unit area, a specific area this force is acting, and we know force acting on unit area is actually a pressure, so you will get the 4th mark. Is it clear the concept how the gas molecules are able to exert force on the wall of container? So it is very important to understand this concept that gas molecules are continuously changing the direction. When they change the direction, they exert force, and force acting on the unit area will create a pressure. So this is an important part. You will find this question very common, that why gas molecules exert pressure on the wall of container, or explain in terms of momentum, or sometimes they say how the gas molecule exert pressure on the wall of container. So you can use these points. This is a fixed way to answer. So gas molecules are moving randomly, they changes the direction. When they changes the direction, there is a change in momentum. Due to the change in momentum, they exert force, and force acting on unit area will create a pressure. So the pressure of a gas refers to number of the molecules colliding with the wall, as well as can be explained in terms of momentum. And for gas molecules, the momentum is continuously changing as their direction is changing. And we should be able to explain the temperature of the gas in terms of movement of the particle. So temperature of the gas refers to speed, or speed refers to kinetic energy. So whenever there is a change in temperature, there will be a change in speed or kinetic energy. If temperature increase, speed or kinetic energy will increase, and as the temperature decreases, the speed or kinetic energy will decrease. So if you have two containers filled with the same number of the particles, same identical gases are there, but at different temperatures. Container A, the gas molecules are at 60 degrees. Container B, the gas molecules are at 30 degrees. In which container the gas molecules are moving faster? In which container the gas molecules are moving faster? That is right. A is the correct answer because higher temperature means moving at a higher speed. As they are moving faster, the kinetic energy will increase. Then what is the concept of the Brownian motion? The Brownian motion is refers to a random motion of the particle, random or zigzag motion of the particle. And why the particle undergo a Brownian motion? Because the heavy particles are colliding with a lighter particle. Example, you will find that the dust particle does not settle down quickly, or why the smoke particle move randomly. So example, if this is a dust particle, so if it is a dust particle, so the dust particle, we are able to see the dust particle, but air molecules, we are not able to see the air particles with a naked eye. So what happened? These air particles are continuously colliding with the heavy dust particles. So when these lighter particles colliding with a heavy particle, what it result? It will create a resultant force, and due to this resultant force, what we observe the motion, that dust particle continuously changes the direction and moving randomly. So this zigzag motion of a molecule is known as the Brownian motion. But if you draw a Brownian motion by a curve, like you mentioned this, that is wrong. It's not a, because for a short distance it must be a straight line. It's not a curvature. For a short distance it should be a straight line. So whenever you're representing a Brownian motion, you should always use straight lines, but not in a specific direction, continuously changes the direction, but it should be a straight line. Is it clear the concept of the Brownian motion, the random zigzag motion of the molecule? We already discussed this in chemistry as well, the chapter 1 of chemistry. So it's the same idea. If you want to see or observe the Brownian motion, so for that purpose, what we can do, we can take a glass cell. Glass cell means a cell made up of glass, and inside we have smoke particles. Smoke particles, we can see, air particles cannot be seen. When we look through this microscope, and what is the purpose of the lamp and the convex lens is to make, to illuminate this, otherwise in a dark you will not be able to see these particles. So the purpose of this convex lens is to focus the light in the cell, so you are able to observe this. So when you will observe any specific smoke particle, what you will observe its direction is continuously changing. So when its direction is continuously changing, what we call this, we call that as a Brownian motion. So random and zigzag motion of the particle due to continuous collision with the lighter air particles cause a random motion, which leads to Brownian motion. Is it clear the concept of the Brownian motion? Any doubt? Then effect of temperature on the motion of the molecule. What is the effect of temperature on the motion of the molecule? So when we increase the temperature, the kinetic energy, the molecule gain kinetic energy. As they gain kinetic energy, they will move faster and they try to move away from each other. That increases the separation, or the size will increase. So example, you have you have a solid initially at 20 degrees centigrade, and this is the arrangement of particles inside the solid. Now what you did, you placed this solid above the Bunsen burner, or by any source of heat. You provide heat energy. So what happened to the speed of the particles? So when we supply heat energy to this solid, the speed of the particle will increase, and as these particles speed increases, the distance between the particle will move or try to move away from each other. So that as the temperature rises, what we will observe there's a slight change in the size. Like example, now the temperature, originally it was 20, but now the temperature, example, 150. State is still solid, it is not melting. So this was solid at 20, you supplied heat energy. Now the solid temperature rises to 150. So what are the changes you will observe? The changes which you will observe: number one, you will find the speed of the particle increases, the particle will move faster. The second thing what you observe, that the particle move relatively away from each other. So as the particle move away from each other, they are vibrating at a high speeds. So they are moving away from each other. So as a result of this movement away from each other, what happened? The substance will expand. So when we supply heat energy, even it is a solid, liquid or gas, the substance will always expand. If the state is not changing, then the substance is expanding, the size is changing. But with the naked eye, it is difficult to observe this expansion. But if there is a greater change in temperature, then we are able to observe this expansion easily. So whenever we supply heat energy, the substance is not changing the state. Then what happened to the substance? Number one, its particle will move faster, the kinetic energy of the particles will increase, and the size of the object will also increase. So in short, when we are supplying heat energy, so when we heat a substance and in that example state is not changing, number one, what we'll observe, the temperature increase, size increase, or we can say volume increase. What happened to density? Will it increase or decrease? When we heat a substance, example state is not changing, we observe the temperature increases, size increases, volume also increase. But what happened to density? It will increase or decrease? Yeah, that's good, Afreen. The density will decrease. Why the density will decrease? Because what is the concept of the density? Density is mass present in unit volume. So how much matter is there, how much mass is there in a unit volume? You can see the amount of matter does not change. If this was say 2 gram, this will also be 2 gram. So mass is not changing, As the volume increases, what happened to the density? It will decrease. So this is what happened when we supply heat energy. These are the changes we observe. The temperature increase, the size increase, the volume increase, but the density will decrease. And what happened to speed of the molecules? That will increase. The kinetic energy will also increase. Is it clear? When we are supplying the heat energy, what are the changes we observe? And opposite will happen if you are cooling the substance. So when heat is supplied or heat is removed, what are the changes we'll observe? Number one, the temperature. We are talking about temperature. Size or volume, density, mass, amount and speed of the molecules or particles, or kinetic energy of the particles. Mass refers to the number of the particle. As it is not changing, the mass won't change. So when we talk about when we are heating, temperature will increase. For increase, I will use the term I and C. So it will increase. But when we are removing the heat energy, the temperature will decrease. What happened to size? When we are supplying heat energy, the size will increase. And when we supply heat, we remove heat energy, the size will decrease. What happened to density? That will decrease when we are heating, but density will increase when we are removing the heat energy. The mass of an object remain constant until unless the particle number of the particle change by any mean, otherwise it will be constant. Mass does not change. Speed of the particle, it will decrease, and kinetic energy decrease here, whereas speed of the particle will increase, as well as kinetic energy that will also increase. So, and the separation of the particle will also increase. So whenever we are supplying heat energy, the substance changes the size, we call that as expansion. And when we remove the heat energy, we call that as contraction. How the size is decreasing? Because what happened when we remove the energy? When we remove the heat energy, the particles still have space. So these particles in general, what they do when we remove the heat energy, they come closer to each other. So as the particle come closer to each other, the size will decrease. Is it clear, this example? Any question or a doubt? So when we supply heat energy, the size change we call expansion. When we remove heat energy, the size decrease, we call that as contraction. This is just the whole explanation what I just discussed with you. Now, what is the definition of evaporation? In this session, we'll discuss the difference between evaporation and boiling. What is the difference between evaporation and boiling, and how they are similar first? In evaporation, the liquid turned into a gas. In boiling, also the same thing happened, liquid turned into a gas. That is a similarity. But how they are different from each other, there is a difference, a big difference between them. If you have a container which is filled with liquid, and you leave this container, like example, you take a glass, fill it completely with water and leave it for some days, like example 5 days or a week, what you will observe, you will observe the level of the liquid changes after 5 days. So what is the reason why the level of the liquid changes after some time? So these blue spots are representing the liquid particle. So what happened in evaporation, basically the particles which are there at the surface, they absorb energy from the surrounding, they take energy from the surrounding and they go out from the liquid. So when the particles at the surface take energy from the surrounding and they go out into the atmosphere, this change is known as evaporation. So the vapors are formed, the gaseous state is formed, but not at high temperature. Where in boiling, what happens? When you supply the heat energy to a liquid, so at a certain temperature, these liquid molecules are start to turn into gaseous state, or the liquid is changing into a gas. So when you supply the heat energy by using a burner or any other source of heat, so we are supplying the heat energy, what happened? These molecules gain energy from the source and the molecules can go out after gaining energy. So this will turn into a gaseous state and it will produce vapors at a high temperature. So this process is known as boiling. So evaporation happen at the surface only. The molecules at the surface gain energy and go out. Whereas boiling, what happened? The molecule gain energy from the heat source and at a certain temperature they go out. We call that as a boiling. So what are the differences here between evaporation and boiling? Evaporation occur at the surface, where boiling can occur anywhere or throughout the liquid. So boiling can happen throughout the liquid, where evaporation can happen only at the surface. In boil, evaporation is a slow process, it happens slowly. Boiling is a fast process. Quickly the vapors escape. Evaporation occur at any temperature or at a range of temperature, where boiling occur at a fixed temperature. At a certain temperature the boiling can occur. Evaporation, when a liquid is evaporating, there is no bubbles, you will not see any bubbles, but when the substance is boiling there will be bubbles. Is it clear, the concept, the difference between the boiling and evaporation? Any doubt till this point about how evaporation and boiling are different from each other? So boiling is a fast process. We have to supply heat energy. Here in evaporation, when a liquid turn into a gas, We don't have no heat sources required. But here for boiling, you have to supply a heat energy, so you need a heat source. Without a heat source, this boiling cannot happen. So when a liquid below its the boiling point, as you can see here, these are the liquid particles, example at 20 degrees centigrade. Less than a minute left, so I'll share another link and continue this discussion of evaporation and boiling.